Good morning and good evening, everyone. Welcome to the technical session 5A of a fourth international conference on WS4. Due to COVID-19, we all are going through a new normal phase, and the team of WS4 wish you a very safe and healthy time for you and your well-wishers. We are constantly trying to overcome the challenges that research community is facing at different levels. We at the Global Knowledge Research Foundation are fully committed to contribute and enhance the digital experience in research activities. To continue further, this conference has received tremendous number of submission, which has across more than 700 plus number and 20 plus countries marked through a direct submission and special sessions, out of which 142 papers were accepted by the Technical Review Committee. Once again, we all would like to congratulate you for your research work and to be a part of this success story in a fourth version of this conference. Further, I would like to welcome our session chair to take on this session, Dr. Durgesh Kumar Mishra. He is a professor in CSE and director at Sri Aurobindo Institute of Technology, Indore, Madhya Pradesh, India. He has a more than 10 years of experience. He has been a consulting to Sales, Tax and Labor Department of Government of Madhya Pradesh, India. Welcome to you, sir.
Thank you. Thank you.
Now I would like to invite our first presenter. It's Bartos Koval.
Hello everyone.
The timing कितना है? How much time you are giving the participants?
Each presenter will get 12 minutes for presentation and 3 minutes for question answer.
Yeah, please.
Good afternoon and welcome to the session of World Conference on Smart Transit System.
Yes, Parthos, you can go ahead with the presentation.
Okay.
Due to COVID-19, we all are going through a new
Start.
Team of World S4 system safe and healthy time for you.
Hello everyone, I'm Bartosz from Poland. At the start, I mentioned that one of the futures of open government is a concept of smart city. Smart city is a response to constantly growing number of residents and the need to improve of functionality of the entire city system. Therefore, in this presentation, I will present the model of the open data system, which was modulated after the real e-system for e-services data flow of the real Rzeszów city. Let's start talking about Rzeszów city. The Rzeszów city is located in the southeastern part of Poland. It is classified as a medium-sized city and is one of the fastest growing cities in Poland. This is according to the studies developed by the few universities like Vienna, Delft, and Ljubljana. They state that Rzeszów is a highest ranked Polish medium-sized city in 2017. So why we choose Rzeszów? Despite the fact that it is the smallest Polish metropolitan center, Rzeszów is the fastest developing Polish medium-sized city, with some factors ranking the highest among Polish other metropolises. For example, the most rapid growth is about 56% of real GDP of all Polish cities. GDP, that means gross domestic product. And also Rzeszów has the fastest growing number of inhabitants, that is about 16%. That's about 40,000 inhabitants in 50 years. So how Rzeszów changed to smart city? Its concept was mentioned about 5 years ago at the meeting of City Council. Technological development combined with significant increase of inhabitants in Rzeszów brings very dynamical and hard changes in the way the city works between inhabitants and administration. One of the solutions aimed to creating strategies for future is the concept of so-called smart city. It's really difficult to define the term smart city itself in Poland, but in the context of the city of Rzeszów, there are 6 modules that ensure the city is smart. This is our these 6 modules like economy, mobility, management, environment, inhabitants, and life. Economy means using innovative and flexible solutions to increase the efficiency and productivity of the local economies. Mobility means that using of creativity and advanced technologies to manage transport and communication. Management, this is all about city management and administration. Next one is environment. This module is about environment and using of energy resources, as well as smart and water management. Next one is inhabitant module. This is all about human factor, such as education, involvement in public life, and influence in society. And the last one is life. This is about quality of life in the city through universal access to public services such as housing, culture, environment, and local security. This is our 4 requirements for e-services in Poland. All services must comply with these 4 regulations. Also, they should also comply with minimum requirements for public registers and IT systems. In order to 100% guarantee the stability of the systems between other cities, the following assumptions are made. Data integration is achieved with other systems by supporting relational databases, that's ODBC or JDBC. The data systems is capable of both synchronous and asynchronous communication to independent modules, and data exchange is used by XML standard. This figure presents the real data flow for e-services in Rzeszów. Here I must draw your attention for a division of e-services. The national, this is upper level figure, and the city level is the below. Let's talk about national level, the EPUAP, this module. This is electronic platform for public administration services for citizens with public administrations. They cannot send message between other citizens. This is messages in one uniform and standardized way. Next one is PCA IP modules. This module is another name for e-administration, of course, in national level. Then how communication works between national and local level, these functions. The communication with EPUA, PCIP, and the web portals takes place via web services. All messages between the domain systems and the city levels is secured with WS security mechanism. This is electronically signed messages, ensuring that communication is 100% guaranteed. Communication between user and institutions and between other institutions is done only by mailboxes on EPUB platform. Each registered user has its own mailbox to which he is able to send electronic documents. Now it's city level e-services. I'm going to start for the upper right module, Proton. These modules collect and create electronic documents between national and city level. It contains the interfaces for verification and signing with electronic signature, ensuring the 100% legality of sending documents. Next one is a broker module. This module integrates with EPUAP system between national and city level, using the electronic documents Proton. A broker is a required element in receiving and processing all the data from external systems. The broker must perform data conversion, determines the compatibility of all the data between these 2 levels. Next one is eBoom. eBoom is a portal for electronic office for resident services. This portal allows the user to access many useful services, including the city tax portal, the spatial information system, allowing the submission of a garbage declaration, e-child portal that has a recruitment portal for schools and kindergartens. The access to this module is possible only through a secured login with use of trusted profile. Next one I will mention is e-communication. This module enables data exchange between external users that are not users in Rzeszów City. Communication is done only by text information like chat, email. This is email are not different from app-WAP platform, or done by SMS gateway. Next module is about community and budget. This is about management of city budget module that include voting system and project proposals. Next module is e-education. E-education provides additional services related to the electronic recruitment for schools and universities. It supports the educational process of the city, including the improvement of the school parent relationships. Next one is e-council module. This is a module only for city council that can send online transmission of council as well increase interpolations. Last module I will mention is database. Database module is task is simple. It's only to transfer data between components and application included in the whole city system. I must mention why there is no e-health in this level, because e-health works in the national level, not city level. I know due to lack of time, I will skip the rest of the modules. This is about how smart city can influence development of public transport. In the last 5 years of this smart city in Rzeszów, there were 6 systems that have been implemented. This is on the right side of presentation. In total, the system mentioned include over 50 traffic lights in Rzeszów. There are smart traffic lights that can change the traffic, how the counting cars. Next one is 17 boards that allow to change the context. Thanks to that, it's possible to inform drivers about change the traffic, as well as recommended detours. This is a feature in the upper left. This is this board. This system also has local bus information boards informing when the bus will arrive. This is a feature in the upper left. And the systems also manage parkings and shows in the smartphone apps where there is free spot in parkings in Rzeszów City. According to the research to the City Hall in 2019, these systems help the relieve traffic jams in about 60%. In the last time, I must mention about how smart city can influence GDP. In the left, we have GDP in 2010 from Wojciech and Rzeszów, and the right one is in 2018. Colors show percentage increase of GDP. We can see there's a very significant increase in GDP from about 50% in 8 years. I note that GDP not only depends on the smart city concept alone, but it certainly has a big influence on it. This is about ending of the presentation. Thank you for listening. Please ask if you have any questions.
Hello. Yes, any question from the participants? I have one question. This roots. This how how can it influence the GD, but how to maintain the privacy in the case of a smart city development?
Privacy. This is a whole issue about privacy. We have GDPR in Europe to measure and ensure the privacy of the city data. Management of this data is by City Hall. Then these administrations ensure that the data is safe.
Okay, right, thank you. Any other question from the participants?
Here all participants, the chat board is open. So if you have any particular question, you can directly write to the chair as the presenter also.
Right. I think there is no questions. Now I request, please call the second one.
Okay, so I would like invite our next presenter, so Alexander.
Alexander. Alexander is ready. Yes.
Okay. Do you listen me?
Yeah.
Do you hear me? Yes.
Yeah.
Yes. Okay, I begin. Thank you very much for the invitation on this conference. It is my second visit to this conference, and I think that it is organized very well. It's very interesting reports, and I think that I'll try to take part in this conference the next year if you will invite me and if I write today. I'll tell you about the very important themes for our Russia. It's they're creating the National Digital Agricultural Platform. This year, Russia got a strategy for agricultural development, and the ambitions, goals you may found there. For example, the import of our country, agriculture import of our country will become $45 billion 2024. The agenda, the main issue is how to create an agricultural platform that will ensure this convergent or purposeful and sustainable development of our agriculture economic. The points I will put into my report are shown on this slide. Problem statement. There are a lot of different approaches and methods that I had to take into account. Very important questions is make the criteria for methodology choice, and then about convergent strategic cognitive model. I will tell you in the foundation of this approach. It's the author's approach and the component of the platform. It's a very hard work. There are in report for this work more than 3,000 pages, and now I will tell you only a small part of this work. We have to construct a digital agricultural platform, taking into account national goals. It's the upper level of goals of our country development. Then for the agriculture, we take three main goals, objects: food security, competitiveness, and quality life. And then we put into this system some blocks that impacts on the process of achieving the goal. We worked out some risks in digital development of agricultural sector. Here you can see some main blocks of these risks and of the problem. And these risks can be connected in the closed loop closed loop that may create a possible degradation of the agriculture, and these loops create their positive feedback. We have to make the agricultural platform digital, which will cut this loop, which will break this loop. For example, we may see duplication costs, lack of system flexibility, digital logistic breaks. All these blocks we study very detailed. There are a lot of methodological approaches, you know, perhaps this too. Something about, I may tell you about that there are about 300 cognitive approaches, architecture, for example, and there are many architectural approaches in different countries. There are different architecture approaches. The strategic analysis and planning, we used project management, quality management, and so on. And very important to use flexible design technology. All of this, artificial intelligence and so on. I will tell you only on the first and the second point of this picture. For example, we took the framework from the USA digital, for example, and we took this framework and created the framework for our agricultural fields of sector of economy, but the main agricultural platform we have been created using the architecture approach from India government, and I took this framework. And it consists of some connected reference models. You can see on these slides the main models. We change some models, and we create the system of monitoring the demand in information technology, for example. And I will show you only one framework of only one reference model. It's a business reference model. We took the framework of the reference model from it looks like the reference model like in Indian reference model of the architecture of Indian digital government. This every model looks like these schemes, looks like this model in every reference models. In every reference model, you can find 3 levels. For example, for business reference models, there are 3 levels, goals, and in these goals we make the strategic modeling, the organization which support the achieving of these goals. We have got a lot of programs and projects in Russia, and on the first level, on the upper level, we try to connect all these things. Organization that support the achievement and benefits and results. Thank you, thank you very much for Indian suggestion to make the architecture in this framework, we used it in our creating the methodology of agricultural platform. Very difficult issue for us was find the criteria for making a choice of the methodology. There are 40 goals in the in the strategy agricultural economy sector. And
dear presenter, you have last 2 minutes.
Yes, and we take only 7, and three methods we used. The convergent approach we use, the approach is based on the method of inverse problem solving methods. We used the cognitive modeling and genetic algorithm to support the inverse problem solving to get the ambitions, for getting the ambitious goals. The convergent conditions, we took the method of the inverse problem solving on topological spaces, quantum algorithm, genetic algorithm, and controlled thermodynamic and many others. Cognitive modeling helped us to make the decision more optimal. We use for this the genetic algorithm. Some questions we put onto the future. Very many questions, very many issues and factors have non-formalized characteristics, and we have to find, and we use for decision making the cognitive modeling. It's very interesting with big data analysis and so on. There are many cognitive architectures, and we have to we have to make more correct choice in cognitive architecture. And in this work, only some of reference model was considered, and now we are making another reference models and models for optimizations of this architecture. Conclusion, the methodology for creating the Russian digital agriculture was justified. It helps to make the process in agricultural sector purposeful and sustainable. Some methodological approaches were estimated using the 40 criteria, from which only 7 most important criteria were selected. The strategic analysis was carried out, during which the methods of artificial intelligence, big data analysis, cognitive modeling, and genetic algorithm were used. It helped to create an optimal methodology, and discussion issue suggested for the future was suggested. Many references, I have in English many references, and I put here 2 framework you can for framework which used in the USA and India. We take it as a support of creating our digital platform architecture. Thank you very much.
Yes, Alexander, is there any question from audience? No, there is no chat, no question in the chat box. I am having one question. Yes, Alexander, first thing, one suggestion is that I have seen your references, then some current reference should be there. You have to check current reference for the digital infrastructure creations, because you have the references of 2014 and something, okay? Like in 2019, there is one reference. Okay, other is reference are old, only one reference is 2019. And the second, my question is, are you think about that the digital platform supports sustainable? Because you know, it is a lot of reprocessing is required for the digital chunk. how to reprocess it. That is the main problem is there. What about your thinking? Is it sustainable?
Thank you for your questions. I told that we have the report 3,500 pages. In these reports, we describe many methodology. And then we create from all this methodology, taking account Russian situation, we take hybrid methodology, but I show you the example that from the component of architecture approach, we used the framework from India Enterprise Architecture Framework, and every point of the list of methodology we studied and used the many criteria to make a choice what we will put into our hybrid methodology.
Okay, thank you.
Thank you.
Any other question?
Thank you very much. Thank you very much.
Thank you. The conference secretary, I request you to please take next paper.
Thank you so much, Alexander, for presentation. Now I would like to invite our next presenter, Devi Parmeshwari.
Devi Parmeshwari, you has already unmuted. So
Hello.
go ahead with the presentation.
Okay, sir. Sir, is it visible?
Yes,
Hello?
it is visible.
Okay,
Please
okay.
start.
Okay. Hello everyone, myself Sri Devi Parameshwari, full-time research scholar in Department of Computer Application at Kalasalingam Academy of Research and Education. I'm under the guidance of Venkateslu Mandadi, Senior Professor in the Department of IT at Kalasalingam Academy of Research and Education. Here I'm going to present my research work entitled as Healthcare Data Protection Based on Blockchain Using Solidity. It is the little part of my research work. These are all the outline of my presentation. They are abstract, introduction, and
Devi Parmeshwari, I request you, you can just full screen your presentations.
okay, sir.
Devi, I request you to go to directly your work on that. Okay, what work you have done. Okay.
Okay, sir. Here we develop a healthcare system based on blockchain technology. The main aim of this technology is to provide secure and reliable. If you want to exchange the information between the parties, this technology is provide more secure way for transaction. Here I used smart contract based implementation in this framework. This is the introduction part. Nowadays, the blockchain is a emerging technology in various fields. And the main advantage of this technology does not have any central authority between the transaction. Um, it is a full and fully decentralized way for transaction between the parties. It has some features like decentralized transparency and immutability. Bitcoin is the first cryptocurrency was applied blockchain technology by Satoshi Nakamoto. This is the architecture of blockchain. Here this the first block is also called a genesis block. Each and every block is identified by the hash value. So every block is connected through the hash of the previous block. Then each and every block it holds information about previous hash value and hash of particular cache of current block and transaction details. These are the literature review of my work. The first paper is the main revolution of the blockchain technology. Here, this innovation is first implemented in cryptocurrency known as Bitcoin. In Bitcoin, in this paper, the electronic hash is transferred between the parties without the need of central authority. Uh, then this paper explain about the architecture of blockchain and the hash algorithms and etc. Then the second paper is introduced the existing implementation of blockchain in uh, healthcare sector. The number of potential research opportunities in healthcare are also discussed in this survey paper. Then the third paper is propose a new platform for building a blockchain. It is known as Hyperledger. It is based on electronic healthcare record for improving the efficiency and security. Then the fourth paper is propose a more powerful and flexible patient observation through the wearable sensor at any time and anywhere. Then the system reduce the cost and time of the patient and propose the architecture based on permission blockchain. Then the fifth paper is presented privacy preserving a platform for healthcare data in cloud. It has defined a set of security and privacy requirement for the healthcare data system. Then the last paper proposed a new framework named as habits, where security can be achieved with the immutability by smart contracts using the Hyperledger framework. These are all these are tools we have used for my implementation, such as the Ethereum smart contracts and Remix IDE. The Ethereum is the one of the platform to build a blockchain. Then smart contract is a program create a application by using a Solidity language. Then Remix IDE is a open source and online tool which helps the writing a Solidity contracts. Then uh, in this system has the four components such as the admin, organization, doctor and patient. Those components are interact with each other and authenticate through by login. From the diagram, the local server means this application only deployed in the browser. And this slide explains about how the components are interact with each other. The admin is the higher authority in the system. This component only allocate the authorized users and add and remove the hospital information. Then another component is organization, only add or remove the or add or remove the doctor details. Then the role of doctor component is add or remove the patient details. Then view the records of particular patient. The role of patient components add or remove the own medical records. Here I explain about my implementation part. This framework is implemented on Intel Pentium with 4 GB RAM using a Solidity language. In this figure 3 introduces sample code of my work. In this figure 4 explain about how to deploy a smart contract. It contains a JVM module to execute the all transaction. Then the transaction is measured by gas limit. Figure 5 explain about how to run the smart contract. After deploying a code, we will use it for accessing the functions in this application. This figure contains the sample block for add authorized users from admin. In this figure 7 contains the sample block for add hospital details, and it holds the some parameters like transaction has transaction cost and execution cost and etc. Here I conclude my work. In this paper present a system-based blockchain technology for securing assets and medical records. The system built on Remix IDE tool and deployed in the browser. Furthermore, we will design a web-based application to interact with the smart contract. These are all the reference of my work. Thank you.
Okay. Is any question from the audience? No question from the chat box. Yes, my question is Devi.
Yes, sir.
This is I think so. This what you did it. It's a application. You develop in one application.
Yes, sir. Yes, sir.
Yeah, but it's not a research work. But I will request you. This is my suggestion. I
Okay.
request you to convert it into the research part. Okay.
Okay, sir.
So that it will be good for you. What you are doing? Are you doing this PhD or something?
Sir, again repeat the question.
Are you doing PhD or PG
PhD,
course?
sir. PhD,
PhD.
sir.
Then I request you to develop some algorithm. That algorithm
Okay,
you have
sir.
to implement it. Okay. Otherwise, your
Okay.
presentation is very good. Thank
Okay,
you.
thank you,
Thank
sir.
you.
Thank you, sir.
I request next speaker.
Thank you, Parmeshwari. Now I would like to invite our next presenter, Abhishek.
Hello, am I audible?
Yes, Abhishek, please go ahead with your presentation.
Hello, my name is Abhishek, and my project name is Landscape of Monitoring and Visualization of Technologies in DevOps for Classification and Prediction. So, in introduction, I would like to explain the background of the project and actually the uh, need of the project. So, in background, nowadays IT applications are getting day by day. It's user experiences, monitoring big data, machine learning, and visualizations. The world also want you to go through the transformation for accelerating pace in the applications and its infrastructure usage and its growth. So the current system is not available of the monitoring for a single stop as a central stop for all the applications distributed to the particular developers for any process. So an input it's format both
Actually, your internet is
personalities.
so maybe we have.
Now you are able to listen. Hello.
Yes.
All the papers are based on the these three topics only, and we got multiple choices with Hadoop, and also we have used ELK, that is Elasticsearch, Logstash, and Kibana. So I will introduce in the next slide. Uh, so for the background study, to give a single stop, we used ELK, that is Elasticsearch. So the Elasticsearch have three components, that is Logstash, Elasticsearch, and Kibana. That is like ETL, extraction, loading, and transformation. So while extraction, there are some agents or clients you can create and you can install it, that we have created by using APM, and we have installed it on the users APIs and HTTP services, non-HTTP services, multiple service-based components, and from that components, it get varied to the Logstash. Logstash is just a transformation tool, so that you can transform multiple documents which are in the type of JSON, and Kibana is a visualization tool. So APM is nothing but application performance monitoring. APM is designed for backend development, like API creation and all these things. So you can install this agent, like we have written code for the APM. You can add that APM agents on your services. Also the RUM is for real user monitoring, that that is used for languages like Angular JS, which are front-end based, and APM server is just a central stop for them. Like multiple services can deploy their JSONs to the APM server, and from APM server it get deployed to the Logstash, Elasticsearch, and Kibana in that way. So next point of the topic is data collection. After that, we have used isolation forest, local outlier factor, and elliptic envelope. like there is not a proper algorithm designed for the same. So we used these three and its combination to make it proper outlier detection algorithm. So objectives of my project are collecting regular data from the infrastructure, different platforms of the infrastructure in a single stop, that is central, and this leads to improve the end user experience and smoother operation, also to reduce resource cost and to quickly uh, turn around the time. Also monitoring also makes the operational practices audible, like forensic investigation, actually the bug finding ability and detecting ability. Also the log analysis of the data related applications and servers by using multiple machine learning algorithms, uh, like decision tree, naive based extraction. So in the methodology, we have started from Logstash to Hadoop. So Logstash to Hadoop, what is the need of Logstash to Hadoop? So the first point, that from multiple services, we are gathering data in the APM server. From APM server, we are pushing it into Elasticsearch, but Elasticsearch is getting full due to Elasticsearch is the database which is uh, cover of Redis database. So it don't have the ability to store huge amount of data which Hadoop have. So we have streaming live data from Logstash to Hadoop by using web HDFS connector. So I have written added the snip of the code from which we are sending that data from Logstash to Elasticsearch, uh, also from Logstash to Hadoop by using web HDFS. Uh, Elasticsearch, Elasticsearch is holding a 15 days data or 30 days data, which is a small duration. So this is for the live dashboard creation and live dashboard backend database. But for the huge database and for the all the machine learning algorithms, we are using Hadoop database. Kibana is for the visualization tools. By using Kibana, we have created multiple dashboards which are helpful for the user. And Hadoop to Elasticsearch. Hadoop to Elasticsearch is one of the method when we can find out the multiple anomalies, then we can send it to the Elasticsearch for visualizations, live visualizations. So the pipeline logs architecture, we have included APM, RVM, and the next part which we have designed, that is pipeline log architecture. That is for multiple pipelines which are running backend, like in the Jenkins, in Azure, in AWS, there are multiple pipelines which are running backside. So these are the very huge programs. So it takes lots of time, like 8 hours, 10 hours. So we have to monitor them and we have to reduce their turnaround time. So what we did in this we have used a Hadoop cluster. From Hadoop cluster, we are using command prompt is for taking the data from HDFS. In HDFS, the Hadoop store its all the logs. So we are calculating the logs from the HDFS only. So by using shell script, which is inbuilt in the Python module, we have taken that shell module and we have implemented into the Python code. From Python module, we are taking all the Hadoop based logs and we are pushing it to the ELK by performing some um, uh, transformations like JSON format and all these things. So from that, we are showing it in the dashboard, that is live dashboard, so that user can check it live. Uh, the log file is in the code pipeline. From code pipeline, we are pushing, we are taking log file also, and we are combining it in a record, and we are pushing it into the dashboard. So the customized Python algorithm is like we are starting. After that, we are reading data, and we are taking application IDs, which are unique ID for a single program execution log. And from that, we are collecting that application ID, and we are running our shell script, and we are collecting our log data from the HDFS, and we are combining it, and that all are the yarn logs plus pipeline logs, and we are sending it to the ELK. And this is the step for managing the pipelines. Also by using this, we have managed three important points, that is APM for the APIs, REM for the uh, website that is web-based front-end designs and databases like Hadoop by using this type of the code. So the next point of the my project is anomaly detection architecture. Like we are getting lots of data, that is huge amount of data. Like we can say 50 and we are using our anomaly detection of the data. So by using HDFS cluster, HDFS will store all the web HDFS log which are sent by the logstash in the web HDFS server, and our model is inbuilt in a Hadoop database. And by using our model, that is a Spark model, we are detecting numerous types of the anomalies. Like anomalies are like its transaction duration time, its span duration time. Suppose there is a single transaction which are having multiple number of spans in between. Spans are like connection of the database, connection of the API, generating token, etc., etc. So actually we are calculating all these timeline based charts, and we are generating the anonymous data, and we are showing it on the live dashboards. So in this algorithm, we are loading all the logs on the timestamp basis. After that, we are pre-processing. We are doing feature selection on the basis of that. Actually, there are four parts, that is metric bit data, transaction data, span data, and error nudge data. We are combining all this data into a single a point of data frame, and after that we have started its anomaly detection. So we have used three algorithms, that is isolation forest, local outlier factor, and elliptic envelope. Isolation forest is good for anomaly detection, but also we have used local outlier factor. It creates numerous clusters which are based on the small amount of uh, local clusters, and it can detect local outliers, so we can use that also. We are combining this, and we are taking the average which is greater than 2. We are saying it as a anomaly. So anomaly detector algorithm, in that for feature selection and pre-processing, we have designed some graphs, and that are like span duration and the span name. So it is showing some of the points which are outside, belonging outside of the group.
Dear presenter, you have last 2 minutes.
Yes, ma'am. Also, I have plotted the timeline charts for numerous data points which are coming on the basis of the timeline. This is the output type thing, like in which elliptic envelope, local outer factor, and isolation forest, we have combined these three, and these three are detecting, and whose total sum is 2, we are taking that much of the data. So the results, we have designed some dashboards from Kibana. This is the summary dashboard, in which we are telling how many sub platforms exist, how many applications, APIs, users, pods, how many number of Kubernetes pods are executing right now, and we are also telling the application health, which is below application wise, and that is the summary dashboard. This is the response dashboard. We are explaining here the responses of the APIs, responses of the methods, why it is taking that much of the time. The last green bar signal is a clickable thing. You can click and you can check whole thing in detail by using the span. Also, this is the usage dashboard, in which we are telling which application or APIs get used most. This is the infrastructure dashboard. Here we have combined the Kubernetes and various platforms, so that we can say that each service, how much that service is taking CPU, how much that service is taking memory, and all these things, disk utilization, all these things. This is the error dashboard. We are explaining what error has came in which API and what is the problem. This is the page monitoring. This is for RUM, real user monitoring. Here we are monitoring single page hits, single page, all these things, hovered component, which component got hovered many more time, clicked components, etc., etc. This is application monitoring, where we are monitoring the single application by using this. By using this, you can monitor single page and its usage also, and if it hits. This is user monitoring. We can monitor user also, its activities on a daily basis. This is for the Hadoop. While we are taking the Hadoop log, that is pipeline logs, we have managed here, and it is showing its coming time and its occurring time. This is the anomalies output which we have designed, which we have got. I would like to conclude this project. We have used ELK architecture, which is a very good architecture, and by using Logstash, we have did multiple transformations. Also, Kibana dashboards are very useful for the real-time data. Also, we have used Hadoop for the legacy data storing and its machine learning algorithms. So, in future scope, we are trying to hit anomaly on a real-time basis. So, for that, we are using some neural network algorithms.
Okay.
Thank you.
Thanks, Abhishek. I think so. This is a very good project done by you, and I think so. You have to compare with the other what the others are doing, right? I
Yes.
have not seen any comparisons part that already work is done. Okay, you have already done the project work. It's okay. It's good. Thank you.
Yes. Actually, it is a new project that no one has published anything on that
Yeah, yeah,
project.
yeah, yeah, yeah,
So
yeah.
it is the new. So I am willing to compare, but
Right.
we can
Okay.
add.
Thank you. Thank you.
Yes, sir. Thank you.
Thank you, Abhishek. Now I would like to invite our next presenter, Bhanu Prakash.
This is the third last one.
Hello.
Banu Prakash, go ahead.
Am I audible now?
Yes.
Good afternoon, everyone. I am Bhanu Sharma, a research scholar in USICT, Guru Gobind Singh Indraprasth University, India. And my topic of research is dual thresholding based breast cancer detection in mammograms. So, this is table of content. Initially, we will look at the introduction of breast cancer and the mammograms. Then we will look into the various techniques which are used for pre-processing and enhancement of mammograms, various thresholding techniques and classification techniques. So what is breast cancer? Breast cancer is basically a disease in which its cell grows out of control. These cells basically forms a tumor or can be felt as a lump and when seen in a X-ray image. Right, like we can see on the right hand side, mammogram image is shown. So left portion of the image is showing a normal mammogram, whereas the right portion is showing a lump in the mammogram, which is the main cause of the cancer. So these tumors can be categorized into two categories. One is benign. These benign tumors are non-cancerous and they do not invade nearby tissues, and they generally do not spread to other parts of the body, but they can be dangerous if they are pressing any nearby tissue, nerve or blood vessel, etc. The other one is malignant. Malignant are cancerous tumors and they invade nearby tissues very fastly. They move to other parts of the body through the blood stream or lymph nodes, and they are very dangerous for the woman. So a study says that in even in US, every woman is supposed to having 12% chances of being infected from breast cancer. So to overcome this problem, American Cancer Society is recommending the annual screening of breast cancer for the women of age 40 years or more. So to detect breast cancer, various detection methods are there. First one is breast examination. In this mode, the doctor is physically checking for the breast cancer, but reliability of this test is very low. Second one is mammogram. Mammogram is basically using the X-ray technique. Second one, third one is breast ultrasound. It is using sound waves and generally preferred when we need to detect whether the lump or tumor present inside the uh, breast is solid or a fluid-filled cyst. Next one is biopsy. Biopsies are generally recommended for detailed knowledge examination. and generally not preferred at initial level. Next one is breast MRI. These are using magnetic radio waves to generate the internal breast images. So what is mammogram? We are basically using this mammogram images for the prediction whether the mammogram is infected from breast cancer or not. So the mammogram is basically a low dose X-ray image as shown in figure. The breast is placed between two plates, and from different angles, different images are captured, which can be used to identify the depth of the tumor if present, or the shape of the tumor. So again, this mammography is again divided into two categories. First one is the screening mammography, which is basically generally at initial stage and recommended by the American Cancer Society to be conducted on annual basis. And it is basically a routine work and takes 10 to 15 minutes. And if any tumor is felt inside the breast, then we may go for next level of mammography, that is known as diagnostic mammography. In diagnostic mammography, we are basically focusing on a specific portion of the breast which are identified during the screening mammography, and this is generally taking some more time because more expertise is required, and it is generally costly than the screening mammography. Next one is the proposed work. In proposed work, basically we are naming is that computer aided detection of breast cancer. All these CAD related works are broadly divided into three categories. First one is removal of the noise from the input image, which is mammogram in our case. Second one is strengthen and extraction of the features from this mammogram, and these features are then again input to the various classification algorithms to classify whether that image is showing breast cancer or not. So basically the main thing, our topic name is dual thresholding. So dual thresholding means as we are seeing, after pre-processing we are branching into two sides, left hand side and right hand side. Left hand side is doing one level of thresholding, right hand side is doing another level of thresholding, and the resultant mammograms from both the sites are then merged using dot product to form a final mammogram, and from that final mammogram we are extracting the features, and we are classifying the mammogram in benign means non-cancerous or cancerous. So pre-processing, when we talk about pre-processing, so generally when the mammogram image is captured, then some noise is present, maybe due to some technical reason or environmental reason, and some labels and markers which are known as artifacts are present, like to identify the name of the patient, its ID, date on which the mammogram is captured, like shown in the image right hand side. This Gen 3097 is supposed a marker. So when we are extracting the features from these mammograms, so these markers and noise are working as a disrupting elements and may cause the accuracy of the classification. So initially the main target is to remove these noise and markers from the mammogram. So it is basically done left hand side, figure 5a shows the presence of salt and pepper noise. This is what some black and white pixels are spreaded around the mammogram. So these are removed using the median filter. Median filter is what, suppose these matrix is showing the intensity level of pixels of the mammogram. So for each pixel, we are rotating a 3x3 median filter mask, and we are taking its value in either ascending order or descending order. As shown in yellow colored selection, all these values 0, 0, 0, 8, 9, 10, 12, 8, 9 are sorted in descending order, and then we are taking its median value, that is 8, and replacing it with the middle value of the mask, that is 9 is replaced with the value 8, and the same process is repeated for all the pixels. Next one is enhancement of the mammogram, which is suppose figure 5b. Left portion is showing some lines and circular regions on the image. So suppose we want to take only circular regions and do not want to use the lines which are like noise in our case. So these are removed using a morphological operation known as opening of the image, which removes some of the foreground pixels And this is basically done using the structuring element. Structuring element is what? Structuring element basically decide which type of structure of region we want to retain. Suppose here we have taken disk structuring of diameter 11 pixels. So the regions of minimum 11 pixels of diameter of circular or disk shape are retained and all others are discarded. So this is the second portion, is the resultant image, and these are basically used to preserve the foreground region or improve the region boundaries. Second one is image closing. It is very opposite to the image opening. Here we are enlarging the boundaries of the foreground region. Suppose in fifth C image, we are seeing that some black lines and some disruptions are present in the image. So our task is to remove this and get a clear one image. So we are enlarging the boundaries of these uh, black points. So by doing this, these black points will be removed and we are getting a very clear image. And these are very clear and good features can be extracted from this. So now we are going to the first portion of our threshold, which is of left side. So we are using initially very famous Oatshoes threshold, and after getting a threshold value using Oatshoes threshold, we are discarding the pixels whose intensity level is less than this threshold. And of the remaining pixels, we are computing the mean and standard deviation. And using the formula given in fourth step, we are calculating the new threshold. Here C is a constant and its value is taken as 0.9.
Dear presenter, you have last 2 minutes.
Yeah, sure, ma'am. And at last, we are thresholding the image. So this is suppose a mammogram image. This first threshold 88 is our threshold calculated using the Oatshoes threshold, and using this formula, new threshold calculated is 145.5. So all the pixels whose intensity level is less than 145.5 are discarded, and other pixels are used for further classification. Next thresholding is histogram peak analysis. Histogram peak analysis is using the probability density function, which is basically computed for every level by counting the total number of pixels of that intensity level divided by total number of pixels. And from that, we are computing the peaks. Peaks are what? As we can see, this is a peak. Peak means its prior level is having less number of pixels, and its next level is also having a less number of pixels as compared to this level. So it is considered as a peak. So we are at this stage, we are computing all the peaks. And for each and every peak, we are just dividing the mammogram into two classes. First one is class 1, which is level less than that selected peak, and class 2, which is selected levels which are greater than that peak. And now our main target is to compute the interclass standard deviation for all the peaks and selecting the level or peak which is giving the maximum interclass standard deviation using the formula shown on the screen. So when the maximum peak is selected, that is our second threshold, and using that threshold we are binarizing our image. Binarizing means assigning intensity level 0 if intensity level is less than that threshold, otherwise value 1. Now, as shown earlier, we are doing a dot product of both the thresholds to get a resultant mammogram. So now we are getting our actual mammogram from which we are extracting the features. For feature extraction, we are using the deep convolution neural networks LXNet model. So minor modifications are required because that model works on colored images of size 227 cross 227, and classifying categories are approximately thousands. But here we are taking only grayscale images of size 512 cross 512, and total number of classes in which we have to categorize are 2, cancerous and non-cancerous. And for this purpose, we are using MIAS as a database, of which 80% is used for training and rest 20% is used for testing. And for our work, we are getting an accuracy of 93.45%. Thank you. These are the references.
Okay. I think Bhanu,
Yes, sir.
you have to more work on the feature extraction first.
Okay, sir.
And what have you designed any algorithm for that? Have you designed any algorithm for that?
Oh, sir, actually, I have written step by step earlier, but due to shortage of time, I have just gone through very fast, I think.
Okay, okay, okay. But you have to do something for the feature extraction first to design the feature extraction algorithm, and that is very important for that. That is very important because as soon as you get the correct features, then definitely you will get the correct result also. Okay,
Sir,
otherwise it's
actually,
very good.
for
Otherwise, it's very good.
yes,
You have done a very good job, and step by step you have solved it everything. And classification is the important role in this case of to diagnosis the cancer.
yes, sir. Sir, basically, in this approach, we are using deep convolution neural network, and deep learning is basically extracting features automatically. No
Right,
requirement of manual
right,
feature
right, right,
extraction.
right, 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 right. I
That's
understood
why
that.
feature extraction portion is not shown here.
Okay,
So
thank you.
actually, we are not knowing which features are extracted here.
Okay, thank you, thank you.
Okay, thank you, sir.
Please next.
Thank you, Bhanu Prakash, for your presentation. Now I would like to invite our next presenter, Subhash. Uh, Subhash, I'm
Hello?
audible.
Yes.
Please go ahead with your presentation.
Okay. Is my screen visible, right?
No, right now it's not visible. Yes, it's visible.
Hello, everyone. Myself, Subhash. I'm from Karnataka, India. Our paper proposal title is Artificial Intelligence-Based Voice Assistant. I'm a telecommunication student studying in Bangalore. Now, these are the some points I'm going to give brief idea of our proposal. I'll try to explain all of these concepts in 8 to 10 minutes. After that, I'm happy to answer any of the questions. Now, introduction. Let me begin with introduction of our project. Let's consider a scenario out of science fiction movies where we would come home and just start speaking to our personal home computer and digital assistant, which would take care of our most task, which would take care of our most every need, is not too far from being realized anymore. An intelligent personal voice assistant is a software agent that can perform most of the tasks based on the commands given by the user. Sometimes the term chat box is also used to refer voice assistants generally. Enjoying the luxury of always having an assistant at our side who can support us in our daily tasks 24/7, it is making its way into our lives at a rapid pace of adoption. Their functionalities are still limited, but with time, voice assistants will be able to help us with more and more activities. Users can ask any questions they want to their assistants. It can able to media playback via voice. They can search any information via voice. Users can even send a mail, can make to-do list, etc. We all know that voice assistants are going to be a revolutionary technology in future. We should not get confused voice assistants with virtual assistant. Virtual assistants in which people who work remotely and therefore they can handle all kinds of tasks. Rather, voice assistants become more robust. Their utility in both personal and business realms will grow as well. As we all know that voice assistants anticipates our every need. It performs tasks whenever user asks for. This luxury is now available for every people thanks to artificial intelligence based voice assistants. The purpose of our paper project is to create a functional IPA which can do most of the tasks performed by existing voice assistants and the unique features as well which are not available in those existing voice assistants. The best examples of voice assistants are Google Assistant from Google, Siri from Apple, Alexa from Amazon, Cortana from Microsoft. We have all been using it. Now, on the problem statement is when we surveyed about users of voice assistants, 41% of voice assistant users have concern about trust, privacy, and passive listening. There are about 66% people from around the world are using digital assistants daily. Out of that, 80% people are satisfied, 6% people are dissatisfied, 14% people are neutral. out of 66% people, 19% people use them daily. This can be any digital voice assistant, not just voice assistant. It can be any digital assistant. The voice assistants can be improved by some technologies such as artificial intelligence, improved microphone, beamforming. Beamforming is a technique that focuses a wireless signal towards a specific receiving device rather than having the signal spread in all direction from a broadcast as it normally would, filtering noises such as this noise and all. Now let me give brief idea about proposed method. We have designed a method which will try to match with the existing voice assistant and does most of the tasks and the unique features as well. Those which are not in existing ones, we have tried to add some more new features. In general, voice assistants react to voice commands and give the user relevant information about his or her inquiry. Our voice assistant listens to the command given by the user through the microphone. After listening to the user voice, it will say done listening so that we get an idea that our voice has been captured, and it will display what user has requested and acts accordingly. For example, asking the voice assistant for tomorrow's weather, the assistant will decipher the human voice command and then act independently by searching the web for the right answer and reading it back to the user. Now, some of the few features of our assistants are it can remember any person's name. We can set our name and the voice assistant will respond to us every time with our name. Unlike in other existing voice assistants, it can able to tell current time, date, day specifically. It can play any songs or videos or movies on YouTube. Here comes the favorite feature. Every person's like to download any videos or songs on YouTube, right? Our voice assistant can able to do it with just a simple voice command. For example, if you say download Imagine Dragons Believer song, it will download the particular song on YouTube and gets downloaded in the system. As simple as that. We just have to give a command. It can search any content on Google asked by the user. It can able to tell current weather forecast of any location in the world as well. It can perform even simple mathematical operations as well. We just have to give a command like what is 8,000 plus 10,000. We just have to give a command. Now, if you want to search any location we want to go for, we won't be knowing the route. Instead of opening Google Maps and typing that particular location will consume time, right? It can be done in seconds by giving a simple command to our voice assistant. Here comes another feature. We have added unique feature. We all want to know our password is secured or not. Thanks to our AI-based voice assistant, it can able to tell whether the password has been hacked till date or not, and it can even tell how many times that particular password has been hacked. It can even tell jokes, and it can even tweet or like a tweet. The main future of our proposal is security of women's safety. It is the most priority future right now. If some girl or any person is in danger, we have designed our voice assistant in such a way that user just start to say I am in danger or I'm feeling insecure. Our assistant will extract the current location of that user and sends it to the nearest police station and to the concerned relatives saying this person is in danger, so that police officer can able to look into that. It can even translate any word from any language to any language. It can shut down or restart the system. We just have to give it through voice. These are some of the features our assistant is capable of doing. Much more tasks also it can perform. Now let's see some of the existing. These are the widely used voice assistants. Amazon's Alexa, we can see Google voice assistant, Apple Siri. Now let me explain the core of our project. Let me walk through the implementation steps in our proposed project. Voice assistant application work based on two things. One is Google text-to-speech and other one is automatic speech recognition. Google text-to-speech is a Python library and command line interface tool to interface with Google Translate text-to-speech API. It will write spoken MP3 data to a file like object or a byte string. Yes, our systems record the speech and then break it down into the elements, which are later get processed into text. The process starts with the device by gathering audio with the microphone. Now, this is the actual core of the artificial intelligence that enables the voice assistants to answer our specific questions and human commands. Being able to understand and process our questions is the great challenge voice assistants have to master. Meaning, a voice assistant has to be able to understand and process our questions to learn and make use of languages. Then recorded speech waveforms get straight to acoustic analysis. Acoustic analysis is nothing but it is the measurement of sound waves caused by the component contacts inside equipment, which is performed on three different levels: acoustic modeling, pronunciation modeling, and language modeling. In this process of acoustic modeling, it represents which elements were pronounced and what are the words these elements complete. In next process of pronunciation modeling, that analyzes the way elements are pronounced. Is there any accent or other peculiarities of the vocal apparatus? Now, in language modeling, when we come into language modeling, which is aimed at finding contextual probabilities depending on what elements were captured. Now let's move on to results. I'll be showing some of the results which we have got from our AI-based voice assistant. Here you can see we are searching, we are asking voice assistant to search MS Dhoni. So it is opening Google and searching that particular information. Now, if you want to place any song on YouTube, you just have to give a command by saying play me a song. It will play that particular song. If it didn't get that particular song, it will respond back by saying which one you want me to play so that it gets that particular song. Now you can see that song is getting played. Now this is another feature which we have added to check password. If you want to check our password, we all want to know that our password has to be secured. So we just have to give that command and it will check whether that particular password has been found or not. And it will also tell how many times it has been found by hackers. Now this is another feature. If for some girl or any person is in danger, he or she just have to say, I'm in danger, that particular location will be sent to the concerned authorities. It can even tell current time, and it can even show current weather of any particular city in the world, and gives us information about anything, almost anything in the world. We just have to give a command by saying what is supercomputer or who is Virat Kohli. These are just examples I'm showing here. And it can even tell current news, top 5 news of the world. It will show us, and it will read out as well, and it will find that location. If we just have to tell which location, where do we want to go, it will open Google Maps and it will show that particular location. These are some features we have added. Many more features are also there in our project. All this code which have been written in Python, I have used PyCharm IDE. It works in every IDE. I've tested in a Jupyter Notebook, it works very well. I've done in Sublime Text, it works very well. And I'm using PyCharm because it is more environment friendly. These are some references to our paper proposal. Recent, when you come to the conclusion, recent studies show that the rate of adoption of these new smart devices is even of faster than it was with the internet or mobile, as humans are getting more used to technology by just talking with technology. Talking is just a part of human nature, and it makes it even easier to interact with the voice assistant. Thank you. Any questions?
Okay. Okay, that is a good. I think you design a very good application.
Thank you very much.
If you include something on the emotion based something.
No, I didn't use any emotion based logic.
Yeah.
The whole code has been written in Python.
Yeah.
Every feature has been written in Python language, and have used some libraries from Python. It's an open source language, so that I can use any libraries. So I've leveraged those libraries.
Okay. Thank you. It's a good application. Good.
Thank you very much.
Next.
Thank you so much, Subhash, for your presentation. And now I would like to invite our next presenter, the Tanya Sheikh. Tanya Sheikh.
Yes.
Am I audible?
Am I?
Yes, Tanya, please go ahead.
Thank you. Good afternoon, everyone. My name is Tanya Sheikh. I am an electronics and telecommunications student. I am in my final year of my bachelor's. please bear with me. I might be a little nervous because I'm following up after a lot of so much of amazing work. My presentation is quite simple, so we'll quickly get to it. So the project that we did was IoT-based power monitoring system, or basically a smart meter. So the demand of electricity is increasing at a constant rate, and it's being used for so many purposes, and it's becoming complicated to handle the electricity maintenance and the requirements. So we felt that it is important to come up with a way to monitor electricity which is very cost effective, affordable, and accessible, so that everyone is able to do it. And it will also address problems such as theft of electricity, which is a big deal in India. So as per the Central Electricity Authority, over 27% of all power that is produced in India is either lost due to dissipation from wires or theft. So that is up to 2,61,130 gigawatt per hour of power annually, which is enough to light up New York for nearly 2 years. So this power theft is a serious issue. So we will be addressing. So this smart energy meter is designed using a Wi-Fi system, which is ESP2866, and with three major objectives. One is to provide automated load energy reading over an immediate basis. The second is to use electricity, and so it will promote the usage of electricity in an optimized manner and reduce the power wastage. The system can be classified on the basis of two service ends. One is the consumer, and one is consumer end, and the second is service end. So these are the components that we've used. All of them are very basic components. We've used the Arduino Uno controller. We've used a relay, a sensor, a Wi-Fi module, a resistive load, we've used a bulb in this project. And for the software, we've used ThinkSpeak server, which is a free server. So it is, anyone can access it. There are paid servers with a lot more features. We've got the Google server and Amazon's AWS, but we've gone with the ThinkSpeak since it is free. So here you can see the block diagram. Like I said, it's very simple. It will also be very compact, similar to the meters that we are using now, only it will be a little smarter. So you can see the current sensor. Then there is transmitter, the power supply circuit. LCD will be used to simply showcase the readings, or if there's any error, it will show an error notification. And then the next component is the server, which is the receiver, and your local web server through which you are going to access. I hope that the algorithm is visible to everyone. So the first thing is we will be connecting the required sensor and the Wi-Fi to the microcontroller. Then the sensor will process the data using embedded C in the Arduino IC, which we've used for programming. It will then send 80 commands to ESP8266, which is the Wi-Fi module. We will first check if the Wi-Fi module is working. If yes, we will then connect to the Wi-Fi network. If no, it will keep resetting in a loop. So if the Wi-Fi module is working, we'll connect to the network, and the data will be sent through the Wi-Fi using the monitoring parameter, and it will be stored in the cloud. If we are unable to connect to the Wi-Fi, it will keep trying till that's successful. If not, it will pop up, a notification will pop up on your LCD screen. Once stored in the cloud, it will display according to your monitoring parameters. So once you switch on the main current, the current sensor will sense the power utilized by the load. This will give you an output in an analog form. The output of the sensor is supplied as an input to your Arduino board. Now, the Arduino board has an inbuilt analog to digital converter, which will convert the analog input of the power to digital, and this will be displayed on the LCD. The Wi-Fi module will be used to connect to the internet with the monitoring hardware system. The power that is utilized by the load will be displayed on the cloud in a graphical format or whatever format you would like to opt for. The intervals can be decided through programming. You can change the interval, you can change the delay, and it will send updates at that interval. So you can also do it, it can also send the updates within seconds or 10 seconds, 15 seconds, an hour, whatever. So the concept of IoT, I think we're all familiar with that. It enables to connect our normal day-to-day devices with each other through using the internet, or these devices can be controlled remotely. And this concept just provides us the basic infrastructure and opportunities to form a connection between the physical world and the computer-based systems. This concept has been gaining more and more importance as we are seeing more and more wireless devices coming into the market. This is how the ThinkSpeak server looks like. This is how we will be able to um, yeah, make a channel. So you can name it and you can add your fields. So you can add whatever parameters you would like to monitor. You can add those and just tick mark the box right here. The API key is a key which is used for encryption purposes, so that the data will be encrypted. It will be safe and secure. So we've added the API key used in the programming to make sure that this is the channel, this is the key for this specific channel, and the data that we are transferring, it is secure. So ThinkSpeak is basically an open data platform that IoT enables us to collect. It enables us to store, analyze, visualize, and act on the data from sensors and actuators. So for example, with ThinkSpeak, we can create sensor logging applications, location tracking applications, and a social network of things with status updates. So we can have our own home thermostat control based on our location. The primary element of ThinkSpeak activity is the channel, which contains various data fields like we just saw, location fields, and a status field. So after ThinkSpeak channel is created, you can write data to the channel, process and view the data with MATLAB code, and react to the data with tweets or other alerts. The future applications. So the system is affordable. It's affordable enough to meet the consumption of domestic households. It can also be extended to monitor. It can be also extended to monitor. I'm sorry. Monitor smart housing societies, smart cities, as well as factories and manufacturing units. So prepaid meters are soon going to be the new norm. In fact, 3 states, I think in India, Bihar, Maharashtra, 4 states, Bihar, Maharashtra, Karnataka, and West Bengal are already starting to use prepaid meters. So they are going to be the new norm, which will lead a lot of people, will be opting to monitor their energy consumption themselves. So this system works on its own, but it can also be combined with our everyday meters, which are already in place, to simply upgrade them. Some other upgradations that can be added are electricity theft alerts. So you will be getting notified if the electricity theft is taking place from your connection. We can this can be done by simply adding a threshold and a notification alert. We can also upgrade it to calculate the electricity bill, send you a notification on your phone or your whatever application you're using. So for conclusion, I would just like to say that we think that this is an innovative application. It makes the use of Internet of Things to develop and control home appliances remotely over the cloud from anywhere in the world. In this project, the current sensor is used, like I said, to sense the current and display it on the internet using IoT. The system updates, so this proposed system updates the information every 1 to 2 seconds using ThinkSpeak. We have made sure that the data transfer can be made very simple and extremely fast. We can also increase or decrease the frequency of the data. this technology can be accessed on cell phones, tablets, laptops. It's free of cost, and hence can be accessible by everyone without having to shell any money. Um, we made sure that it's simple, is easy to install, and can be used along with and the speed of transfer being up to the mark. This is how it looks. It is quite compact. It is simple. So the yellow box we can see is the sensor. The black one is the relay. You can the blue board is the Arduino Uno board, and of course the LCD screen. This is how the graphical represent. This is a very simplified version of how the graphical representation looks like on the ThinkSpeak server. And so this is how you will be able to see the system monitoring the representation of the data.
Yes.
And that is all. Thank you.
Okay.
These are the references that we've used.
Yes, Tanya, why you are using Arduino, not a Raspberry Pi?
So Arduino, because our group went with Arduino because we were having an Arduino workshop, and we used the Arduino, so we made the Arduino scratch.
Otherwise, if you use the instead of Arduino Raspberry Pi, that will be in the current technology we are using in the Raspberry Pi. Arduino is not used right now. Okay, so that please switch yourself from Arduino to the Raspberry Pi. Okay.
Okay.
Otherwise, your idea is good and it can be implementable. Okay. Thank you.
Okay, sir. Thank you so much.
Thank you so much, Tanya, for presentation. And as we completed all our presentations, once again, I'm thank you to all presenter and our session chair. Now I would like to invite Dr. Amit Joshi for closing remarks.
Am I audible?
Yes, sir.
Yeah, good afternoon, everyone, and hope you are having good time at your own places, if not London, because in London it's really great summer this year. Thank you for joining us for this technical session number 5, and I will put on record the appreciated efforts of Dr. Durgesh Mishra, who have chaired this particular session and spared his valuable time considering my request. Thank you very much, sir, and this is a token of appreciation from our team side to you. Thank you very much for this, and my thanks are also due to all the participants who have presented their papers in this conference. And for the participants, there are two things which I would like to tell: that cycle time of a paper, which we assume for an IEEE conference, is approximately 6, 7, or 8 months when you submit a paper and it gets published. So half of the time has already been passed. It will take another 2 to 3 months for the papers to come online on IEEE. In the meanwhile, if there are any issues regarding the content or the copyright, we will just update the concerned authors and we will take their inputs and move ahead as soon as we can. Please be patient till that time. You will get a regular update from our team. Also, you all will be receiving the certificates of participation, thank you letter, and the payment receipt in your inboxes just after the session is over. Maybe around sometime 30 minutes or 1 hour, you will receive all those things. So once again, thank you very much. And before closing of the session, I would request moderators to click a snap and request everyone to please kindly put on their videos so that we can click this is not a physical conference, unfortunately, but we can have just a click a snap with all the presenters. So just open up your videos so that we can just we will keep it for 20 seconds and then we will move back to our places. Until that time, stay safe, stay happy, and do whatever best you can towards the society. Thank you, Dr. Durgesh sir.
Thank you, Amit.
For sparing your valuable time.
Thank you for inviting me. Thank you.
I think another 10 seconds and then we can wind up this.
Okay, thank you.
Thank you, sir. I assume that being a digital conference, it is very difficult to chair a session because you need to continuously sit in front of a screen for around 100 minutes and then seeing the presentations and commenting. This is what I am analyzing from our experiences, digital experiences, because in physical nature it's much easier, but in digital it's really difficult.
Yeah,
because concentrating on a screen, questioning, answering, and viewing the screens. Anyways, thank you, sir, and we look forward to your support in our future conferences. And to all the participants, we look forward to see you for World S4 2020 in the year 2021 in London, again in summer 2021. Till that time, stay safe, stay happy. Thank you.
Thank you.
For next presentation, I like
Thank you to all participants once again. Thanks a lot. I request to secretary to close the session. Thanks a lot.